Hello, so this is some help on homework 1.1. We know that polynomials can be written in the form of f of x equals some leading coefficient a minus r1 x minus r2 x minus r3, right? And each one of these r's is a zero, right? Is where it would cross the axis. And we will move into the fact that these can be both complex, meaning imaginary, so you don't see them, or non-complex. But in this case, we know that there are real roots at -2. We also know that the leading coefficient is 1. So x minus 2, x minus a -2, so x plus 2, and then x minus 1. So this equation right here should end up being, I think my open math will take it without being FOILed, multiplied out. But if not, multiply it out, making sure you have all 4 parts. You end up with that. Right. This one says to write your answer in factored form. Don't forget to include in an a in your answer. So this is not assuming a is 1. So here we have the same one. So x minus a -2, x minus 1, and there is an a here. We don't know what it is yet. So we have, in factored form, this. But we also know that it crosses at 0, 3, at 0, -3. So when I put 0 in for x, a therefore is 3/2. So my factored form is going to be 3/2 x plus 2, x minus 1. I could, if I wanted to, distribute this 3/2 in. I don't know that it really helps much. Yeah. Write it as like 3/2 x plus 3, x minus 1. I don't know why you would do that, but you could. All right. Same thing is going to happen here. We are using the rational root theorem that says every time you have a 0 cross, you get another factor. X minus 4, x minus 3, x minus a -1, and x minus 3. X minus a -3. Some a I don't know yet. And now I can use this point here, 0, 4, put a 0 in. 4 equals a times -4, -3, 1, 3. 4 equals a times 12 times 3 is 36. Therefore, a equals 1/9. So my answer would be and when I see something like this, where it goes through at 3, at 4. This touches 4 but doesn't go through 4. So when it bounces off an axis like that at -4, we call that having a multiplicity of 2. What that means is that you have x minus a -4, x minus a -4. It happens twice. x minus 3, and x minus 4. And now we want to find out what our a is. Now I just need to figure out what my a variable is, so I'm going to plug 0 in. 0, 1. So 1 equals a 4 squared negative 3 negative 4. So this is a 16 times 12.
-4.
And 192. So a is 1 over 192. All right. Determine the equation. Assume the leading coefficient is either positive 1 or negative 1. This is likely going to be a positive 1. So if I just look at this here, like, this is just going to be, this is bouncing, it's a cubic, it's got the shape of a cubic. It's bouncing, it's going to be x minus negative 2 squared, because it bounces, multiplicity of even multiplicity, times x minus 1. So you can just add that there. We get your squared. All right, doing the same thing here. Bounces off here. This is a negative 1, right? Because it's opening down. Looks like a 4th degree polynomial. So you're going to go x minus your negative 2 twice. Or not, just once. It doesn't bounce. It crosses through. Sorry. And then x minus 0, that piece. And this is where it bounces. X minus 1 squared. So you get y equals negative 1, x plus 2 times x minus 1 squared. Right? All right, so this one doesn't give us a graph, it just gives us the numbers. So you have y equals, and this is going to be a 3-degree polynomial, so it's going to be this 3 times. This is a root, a multiplicity to it, x equals 5. So that happens twice. And then a root at x equals negative 2. So you get that one. And then you have a 0, 10. 0, negative 10. So negative 10 equals a times negative 5 times negative 5 times 2. A equals negative 1/5. So you go there. All right, hopefully this has been helpful. I think you'll see that most of these are very similar. Again, this multiplicity is when it bounces off. Bounces off here, has a multiplicity of at least 2 there, even multiplicity here. Crosses through there, so no multiplicity. Even multiplicity is when it bounces off. All right, so I'll run through this last one right here, and then this number 12, and then I will post this. All right. This has a 0. When is this 0? Add the 3, divide by negative 2, negative 3/2. The x-intercept then is negative 3/2, comma 0. Multiplicity, 3. Okay. Crosses through. This one, 0 at 1. X-intercept at 1, 0. Multiplicity of 2, bounces. This one, 0 at negative 1. Intercept at negative 1, 0. Multiplicity 1, crosses through. Okay, hope that is helpful. Oh, and the power of this was 1, 2, 3, 4, 5, 6. There we go. All right. And the y value of the y-intercept, just plug in 0. -1 squared, -3 cubed, and 2. So 1 times -27 times 2 is -54. Great. Thanks so much.